guys, welcome to my introduction on Pythagoras. So this is a very important one for you all. Everybody needs Pythagoras under their belt. So let's get cracking. First of all, a few notes on Pythagoras. It's been around for thousands and thousands of years. The ancient Greeks were obsessed with their triangles, and Pythagoras was one of them. Now I always think it's really cool that we still use something that is as old as Pythagoras' theorem, and we probably always will. It has lots of real life applications, so as a maths educator, I get asked a lot, when am I ever going to use any of this in real life? Well, Pythagoras is one of the big ones. It has lots of real life applications. I have quite a few builder friends, and they tell me they barely go a day without using Pythagoras. Cartographers use it when they're drawing their maps, and even something as simple as measuring the size of your TV screen. So TV screen measurements are given by the diagonal dimension of your screen. So from like the bottom left of your screen to the top right, that's the hypotenuse of a right angled triangle. So on that note, Pythagoras can only be used in right-angled triangles. If you haven't got a right-angled triangle, it's not time to play Pythagoras. Unless, of course, you can do something to split your triangle into two right-angled triangles, and then you can play Pythagoras like that. In this video, we're just going to be going over very simple questions. Later on in the playlist, there will be harder questions and some exam-style questions too. So, down to business, what is Pythagoras' theorem? So, Pythagoras says that for any right-angled triangle that we label this way, so C, it's very important that C is always the hypotenuse. It's always the longest side of the triangle. It doesn't matter which side you choose to be A or B, but personally, this is how I label my triangles all the time. A is my height of the triangle, and B is my length of the triangle. So for any right angled triangle like this bad boy, Pythagoras says that the length of A squared plus the length of B squared is equal to the length of C squared. A squared plus B squared equals C squared. So let's get down to business and have a crack at using this. Okay, for our first set of questions, we're going to be interested in finding the length of C, the length of the longest side of the triangle. So looking at this chart on the left then, first thing that I would always recommend doing is labelling your triangles. So if we call that side A, that side B, this guy's side C, then we know Pythagoras says that A squared plus B squared is equal to C squared. So now if we substitute in our values for A and B, A is 3, so we get 3 squared, B is 4, so 3 squared plus 4 squared will give us C squared. 3 squared is 9, 4 squared is 16, so 9 and 16 is equal to C squared. That's going to give us 25 equals C squared. Now if we square root both sides, that will tell us that C is equal to 5. So the length of the hypotenuse is 5 centimetres. Job's a good one. Okay, let's take a peek at this guy on the right then. So for our first job, let's label it A, B, and C. Then if we substitute our values into A squared plus B squared, we're going to get 12 squared plus 16 squared equals C squared. 12 squared is 144, 16 squared is 256. Now 144 add 256 will give us 400, so 400 equals C squared. Therefore Now if ever you see this little 3-dot triangle in maths, that's math speak for therefore. So therefore, if we square root both sides of that, that would tell us that C is equal to 20. So the length of our hypotenuse here is 20 centimetres. Now you're probably noticing that with both of those examples, our answers have worked out nicely. We've got nice whole integer solutions, and we didn't really need a calculator, although square rooting 400 might have been a bit tricky, but the fact is we could do that without a calculator. Now when you get a set of three numbers that work out nicely like that, so a squared plus b squared does equal c squared, where a, b and c are whole numbers, these are called Pythagorean triples. So for example 3, 4 and 5 are a set of Pythagorean triples because 3 squared plus 4 squared equals 5 squared. Exactly the same with 12, 16 and 20. That's another set of Pythagorean triples because 12 squared plus 16 squared equals 20 squared. Now this doesn't always happen, and in fact in most questions you don't end up with nice whole number solutions, so we do need to bust out our calculator. That's what we're going to take a look at next. So before we get going with Pythagoras with our calculator, I want to run over a few very important buttons to us that will make our lives easier. So starting top right, the on button is very useful. Calculator works a lot better when you turn it on. I quite often forget that step. The second one, this SD button, is really useful. So a lot of the time when you're doing Pythagoras, either you'll get an answer on your calculator in a fraction form, or what's called a surd form, where it keeps a square root in the answer. Now usually you will want your answer to a certain number of decimal places or significant figures, so that SD button converts between fractional surd form to normal decimal form. So that's quite a useful chap to be aware of. Now down the bottom you've got this button ANS, A-N-S. Now what ANS does, it stores the answer to your last calculation. So say that I put in 1 plus 2 and pressed equals, then I would obviously get 3. If I was to press the ANS button, I would be putting in 3 because the answer is stored as 3. The next one, the square root button, that's going to be really useful to us to find out what c is at the end. And then finally we've got the x squared button, which squares our numbers for us. So that's going to be really useful to us when we're doing a squared plus b squared. Now in the following examples where we're using a calculator, I've got two different methods. We've got method 1 down the side, where we do this in 2 steps, or we've got method 2 on the right, where we're just going to do this in 1 step. So of course when you're doing these yourselves, you could break them down even further and work out the square of a and then work out the square of b separately and then add them together and then square root that answer. But the two methods that I'm going to show you speed things up a little bit. It's up to you completely how you attack the questions. Maths is all about what you yourself are confident using. So let's get cracking. Okay, so example 1. So we're starting off with decimal values here for our lengths. So we are going to get a decimal value for our missing length. Now let's start off, as always, by labelling the triangle. So let's have that as A, this is B, and this is C. So again, we're just trying to find the length of C. So if we were to play Pythagoras, then we know that 5.8 squared add 2.2 squared is going to give us c squared. Now that's really where the ability to do this without a calculator ends, because squaring 5.8 and 2.2 would really be very time consuming. So let's run through method 1. So what I've done here, I've put in exactly what we've got written there, 5.8 squared, add 2.2 squared. Then I've pressed equals, and chances are that would have given me a fraction. So then I've pressed SD to turn it into a nice decimal form. So here we've got 38.48, and that is the value of c squared. Now remember, every time you press equals, the answer up on screen gets stored in the answer button. So then I've just pressed the square root of ans, and that's given me 6.203, blah 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 blah. Or on the right, I've done it in the one-step method, where I've just done the square root of a squared plus b squared. So if we were to rearrange Pythagoras at the start to make c the subject instead of c squared, we would simply square root, and we would get c is equal to the square root of a squared plus b squared. So that's our one-step method. So here, if we were to do this to one decimal place, we would get 6.2 centimetres. So have a go at putting that into your calculators yourself, see how you get on, work out which method you prefer. Again, if you even want to break it down even further, work out the squares separately and things. That's completely up to you. Okay, let's have a look at another example. So this time we've got 12.1 and 9.6 centimetres. So label our triangle A, B and C. So Pythagoras then would tell us that 12.1 squared add 9.6 squared is equal to c squared. So let's run through the two methods again. So method 1 on the left, I've put in 12.1 squared add 9.6 squared, pressed equals, and then pressed the SD button. So at the moment that's given me c squared equals 238.57. Then to work out c, square root the ants, and that's given us 15.44, etc. Method 2 on the right, the one-step method, I've done the square root of 12.1 squared, add 9.6 squared, pressed equals, and pressed the SD button. So again, we've got exactly the same answers using the two methods. So to one decimal place, c on this triangle will be 15.4 centimetres. Jobs are good. Okay, so we're not always looking for c. We're not always looking for the hypotenuse of a triangle. We might also be asked to look for the length of A or the length of B, one of the short sides. So in that case, we need to do a little bit of jiggerypokery with the formula. So when we're looking for A, we start off with a squared plus b squared equals c squared. Then we want to get a squared on its own, so we take away the b squared on both sides, and that gives us a squared is equal to c squared minus b squared. Or if we're looking for b, again we start off with a squared plus b squared equals c squared, and we want to make b squared the subject, so we subtract the a squared, and that tells us that b squared is equal to c squared minus a squared. If this seems like a lot to take in, try this way of thinking about it. So if we're looking for the longest side of the triangle, we square the two short sides and add them together. So short squared plus short squared gives us long squared. If we're looking for one of the shortest sides of the triangle, we are doing the long side squared minus the other short side squared. So short squared add short squared equals long squared minus short squared equals the second short squared. Okay, let's get cracking then at finding A and B lengths. Okay, so looking at this chap on the left then, if we're sticking with our labelling system, which I would recommend getting yourself used to your own way. But yeah, as I said at the beginning, this is how I label my triangles all the time. So let's call that A, this chap B, and this chap C. So this time, we're looking for the length of A. So remember, if we start off with A squared plus B squared equals C squared, to get A squared on its own, we take away the B squared and get A squared is equal to C squared minus B squared. So if we substitute our numbers in, we're going to get A squared equals 10 squared, which is 100, minus 8 squared, which is 64. So here we're going to get A squared equals 36, and then if we square root, A is equal to 6. So the length of A on this triangle is 6 centimeters. Jobs are good. Okay, so if we check out this guy on the right and use our same labeling system, then this time we are looking for B. So to get B squared on its own, we would take away the A squared and get B squared equals C squared minus A squared. So if we substitute our numbers in, we get B squared is equal to 15 squared, which is 225, minus 9 squared, which is 81. So that's going to give us B squared is equal to 144. So if we square root, that tells us B is equal to 12 centimeters. So that's our answer. B is equal to 12 centimeters. So again here, we've got two examples of Pythagorean triples, two examples where A squared plus B squared equals C squared, and everything is nice, whole, integer numbers. Okay, so let's check out two questions where we're going to need our calculator. Okay, so again I've got the two different methods on the left and right. Just remember that this time, instead of adding two things together, we're going to be doing a subtraction, because we're going to be looking for one of the shorter sides. So, start off as ever by labelling our triangle A, B and C. So we're looking for A. Now we know that to find A then, we're going to do A squared equals C squared minus B squared. So if we substitute the numbers in, we got 21 squared minus 7 squared. Okay, so let's look through the method on the left first of all, method 1. So I've done 21 squared minus 7 squared, and that's given me 392. So A squared here is 392. Then I've pressed square root of answer, and that square rooted 392 for me. And that now tells me that A is equal to 19.79898, etc. Or with method 1 on the right, the one-step job, I've square rooted C squared minus B squared from the get-go. So the square root of 21 squared minus 7 squared gives me, again, 19.798, etc. So if we go to one decimal place, then the length of A is going to be 19.8 centimeters. Jobs are good. Okay, let's check out one more. So let's label our triangle A, B and C. So this time we're looking for B. So B squared is equal to C squared minus A squared, which this bad boy is going to be 6.7 squared minus 3.5 squared, which I definitely don't want to do in my head. So it's a calculator question. So on the left then, we've done 6.7 squared minus 3.5 squared, and that's given me 32.64. So that's given me the length of b squared. Then I've square rooted the answer, and that tells me that b is equal to 5.71, etc. Or on the right, where I've done it with the one-step method, we've square rooted 6.7 squared minus 3.5 squared, all in one go. We've got the same answer, so the length of b here is 5.7 centimetres to 1 decimal place. Okay guys, that's the introduction to Pythagoras. Be sure to check out the rest of the videos in the playlist. I'm going to actually as well include a nice little proof of Pythagoras showing you where the theorem comes from. Was this video helpful? If so, be sure to leave a thumbs up and a comment telling me how you get on. For any further information, you can follow me on Facebook and Twitter, and send requests or any feedback you have. Search for Maths with Mouth. Cheers guys.